Good morning, everybody, for joining on a Saturday morning. So today we'll talk about how to build a lakehouse using Azure Databricks and Azure Data Factory. So before we begin, a quick introduction about myself. So my name is Wilson Mock. I have over 20 years of experience in IT. I was a software developer prior moving into the data space. So currently I'm working as a manager of data engineering at Avanan, where my focus is to help clients create, design, and implement a data strategy to transform decision making. Before that, I worked at CAE as a lead data architect, as well as a lead AI architect at Air Canada, in both organizations where I helped them create different AI and data and AI products to help the organization adopt AI and modern AI and data technologies. So if you would like to follow me, I can be found on LinkedIn, C# Corner, as well as GitHub at /Wilson-Mock. In today's presentation, we'll focus on 3 topics. First, we'll talk about what is a lakehouse and a medallion architecture. The second part, we'll discuss how do we develop a data pipeline using Databricks with the lakehouse architecture. And finally, we'll take a look at how do we consume this data using our Power BI, as well as alongside with the Databricks SQL. At the end of the session, you'll be able to design, build your own lakehouse using Azure Databricks and Azure Data Factory. Connect to the reporting data using Power BI with Databricks SQL. So the fundamental knowledge, we expect the folks on the call to be familiar with Azure Databricks, which means basic PySpark as well as SQL and some Azure Data Factory experience would be helpful as well. In this presentation, there are 2 demos. After the first demo, there will be a quick 5 minutes Q&A, and then a longer Q&A sessions at the end of the presentations. All the code you guys see today will be available on my GitHub repo over the next couple of days. Okay, so we'll do a quick recap of what we have learned so far in our data journey. So if you're unfamiliar with Azure Databricks, in our first sessions, we learned about how to get started with Databricks, learned about how Spark works, and you can check out the first video on the left. And on the right is the last sessions where we talked about how to create our data pipeline using Azure Databricks and Azure Data Factory. If you haven't seen any of the 2 videos in the previous video in the series, I highly recommend you check them out after the presentation. So in the last presentation, we created a solution where we receiving data from various different power stations, and the data are coming in every 15 minutes. We develop a data pipeline that read this data. We apply some cleansing rule around it, and then we created a delta table for our power consumption report. So our manager is really happy with our solution that we have produced, and they have assigned additional project for us to work on. As you are working through the various different projects, you quickly observe that you're reading the power usage data over and over again. You're applying the same logic, which you take the file, you might be doing apply some cleansing rule to them. You might structure them a specific way, and then you're using them for each individual project. So this duplication of work is very inefficient, it's time consuming, and it increases the cost of the Azure consumptions we have at the organization. So what is there a better way for us to optimize this? So the first idea you might have is, well, since you're doing the common, the repeatable step where you're cleaning the file, you're reading the file, and then you writing out in a specific structure, it would make sense to perhaps do that once and then reuse it for all your other reports. So, so this process is very it's something that we want to explore more on, as it has a very strong merits about what needs to be done there. So to better understand that solution or that approach, let's talk a little bit about conceptually how we would go about doing that, some of the steps that we would do to build a pre-processing or a common approach. So this is where Medallion architecture are able to help us organize our data. And the Medallion architecture is structured into 3 different layers or zones. So that's bronze, silver, and gold. In the bronze layer, we want to organize our data based on the source system or application that's coming in. This gives us a clear indication where this data is coming from, and we don't need to search around to figure out which data provided this, which application provided this data. Any new data we receive will need to append to the existing data that we have, and we're keeping the data and the structure that we receive as close to the source as possible, or with minimal changes. So since the data is kept as close to the original data as possible, some people refer this layer as raw as well instead of bronze. So an example of storing this data would be in the bronze folder under the application of IoT Smart Grid, and then the data that you're putting in about the power data, it's the power data folder that you would store them in. The next layer is silver. So here the data is organized by a business domain or area. So this is an important step because now we are switching from application-based storage into a business layers storage, which means we need to know who is in the business owns this specific data set. And this is an important step for us because it helps us address any issues that we might have as this data is starting to change, or if we are working on a new project that we have some questions about this data set. We no longer have to find the system owner and then perhaps then find the application, the business area that owns the application to ask any questions that they have. Finding the expert in the area, it's going to be a lot quicker in this case. So the process that we utilize here, we focus on building a common data set that we spoke of earlier. And we want multiple projects to be able to utilize this data. And there's a few things we want to be aligned on those data sets. So for example, if there's any data type issue that comes in, if a data is read in as a string, but it's supposed to be an integer, or it's supposed to be a timestamp, we want to make sure we fix those. If there's any duplicate data that came in, we also want to remove any duplicates, as we don't want this layer to be to have a lot of error in there. We also apply some basic data quality or business rule checks in there. So this way we know the data that are stored in the silver layer, it is proper and it meets the business requirements. And as a result of all the cleaning that we're doing and checking that we're doing, this layer is often referred to as cleanse and conform. So finally, in our Medallion architecture, the last layer is gold. So this layer is also designed specifically for the business, very similar to silver in that sense. Additionally, though, we do more transformation work in this layer. We do more changes processing to the data so that our data meet what our project requirements are. So very common in the AI project, for example, we would produce some training data for AI, right? So this is where we would produce that training data sets. Or in data project, quite often we will produce a data model or dimensional model for reporting purposes. So this is where we will store that dimensional model as well. An example of that is for dimensional model, which we'll dive into a little deeper later on, is where you have a dim table and a fact table, or dim power plants, or fact power consumption. We'll dive into that concept a little more later on in today's call. And because in this layer, we're building up all the data the business is going to consume. Often this layer is also referred to as curated. So now combining the concept of the medallion architecture we just talked about, and now looking at our data project, we can merge the two concepts together, where before it was a pre-processing box that we have, we can replace that and switch it out with the medallion architecture that you see. And the benefit of that is once the data is being filtered and cleansed and applied for business to ready for the business to use, you hopefully will speed up our project in all the individual projects so that we can deliver them quicker to the business. So we're about to dive into the demo. In our first demo, we'll talk more about building a data pipeline for the bronze and the silver layers. So I want to walk through the scenario with you guys first, and then we can dive into the code in a second here. So each of the power station here will send power usage data to the to a landing area that we have. It's called IoT smart grid data. So this folder is currently stored as a JSON format. In our demo, we will step through the process to read this data in JSON and then process them into bronze. When we store this data into bronze, we would create the structure that we based on the application, in this case IoT smart grid, and then the power consumption data set name that we have. And the data will be stored in the Delta Lake format. And the next layer, after we have completed that, then we would move into the silver layer. In the silver layer, we would read the data in bronze, apply the deduplication that we talked about earlier, alongside with the data quality rules, as well as any validation checks that we need to do. And after we have sorted out all the errors that all the data that we require, and we cleanse it, and we filter out all the data that we don't want, then we can store this data into the silver layer. Again, this layer, it's important to highlight that we're storing it based on the business area or business department. In this case, the company has a department called production, right? Area. So so with that, we'll jump right into the demo here. So in this demo, okay, I guess my cluster didn't get started in time. So we'll might have to wait a second here, but we'll step through the code while we wait for the cluster to start up. So as we talk about pretty quickly early on that, in the first block here, we describe kind of what this code is trying to do, as the example I talked about earlier. There's also following right underneath it, we talk about how to configure our secrets, which is the password that we use to access our storage. In this case, the landing area, the bronze, silver, and gold storage layer. So in this demo, we won't be showing you how to set that up, but please feel free to follow the link in the notebook here, so you can set up the same structure as I do. So as we talked about a second ago, in command 2, we need two specific locations. One, we need to read the data from the landing, and then we need to write the data out into the bronze. So each one of them, we'll first define the locations for them. Again, something to note is the landing and the bronze. It's structured in front of the storage account name instead of being a slash. And then the structure, how we store the data in landing, could be very well different than how we store in bronze. In bronze, we're enforcing the structure of a system name, and then the data set name that we have here. And finally, we created a very similar structure with the table name based on the bronze, the system name, and then the data set name here. So it's going to quickly run that. Shouldn't take quick, should be long. Okay, and then the next block we have here, the command 3 is all commented out. It is used to reset the demo yourself. So when you're running through this and you want to restart everything, get rid of all the folders and files you created, you can uncomment this code and run this. For now, for the demo, we're happy with what we have, so we won't need to run the command 3 here. So command 4 usually gets run after command 3 is to create the two parameters that we have. So the first parameter that we have is pipeline run ID, and this is the ID that we will use from Azure Data Factory. The benefit of that is we want to ensure if there's any troubleshooting that needs to occur, we need to find out why this data was written, or if there's any error from this data, we can trace back to which data pipeline or the Data Factory pipeline run ID that actually triggered this pipeline, or that rolled the data into the storage. The next parameter we have is the landing folder. So this essentially is telling us where the folder, which subcomponent of the folder that we need coming from landing. So in our example, in this demo, we're going to read all the January 1st data from 2023 into our bronze layer. As we discussed previously, the data that we're reading in is a JSON file, so we're just using spark.read.json here. So after the data is finished reading, should be pretty quick here. Let's take a look at the schema that this data produced. Let's take another second here. Perfect. So as you can see, this data, we have the measurement date as a string. A date usually, it's either a timestamp or date. So it's very interesting. This is read in as a string. But for now, as we talked about earlier in bronze, we don't worry about fixing this problem. This is something we will carry forward until we need to deal with it in the silver layer. Okay, so now in order to support us to deal with some of the auditing and things like that we talked about earlier, like utilizing the pipeline ID and so forth, we're going to store those data into our table in a second here. So we're going to write them into the data frame first. Basically the data that's coming in. So we have a few parameters that we added in addition to the run pipeline ID that we use here. So we have the processing date, which is just the day that this data is processed. The input file name, so the file name that this data is coming from on the landing storage area, and also when this data was when this file was written to the landing area. And this last one is specifically important for many data sets that we see in the real world, as we need to try to determine which file is the newest. There are sometimes quite often we need to apply data fixes to our data. So so that would help us tremendously to sort out which data is actually new, which data is old. And with that, we'll also do a quick display, which show us quickly what the data looks like in our data frame right now that we have. Again, to keep in mind the measurement date, it is a string, and this is not a timestamp at the moment. So we have a double, a number with the measurement of the power generated, at what location it was generated, which area it was serviced to. So the zip code is in US is where the region or the area of the states that they provide the services to. Since we're running this directly into Databricks, we just provide a sample pipeline ID here. So 3111 is the one I choose. It looks a little bit different when we go and use Azure Data Factory, of course. The processing date is a data I have locally. I believe this is a UTC time that we have. And then again, this is the landing file name. So we know exactly which file it is, where it is, and as well as the modified date that we talked about a second ago. Now, with this data set ready, we're going to write this directly into our bronze storage area. So what this code does is check to see if we actually have a delta table created already. If it doesn't, then we're going to create. If it does, then we're going to append the data on directly, like we talked about earlier, into the Delta Lake format. And if no, the data is not existing there, then we're just going to overwrite anything that exists in there. Okay. Now, so after we created the data set, the next thing we need to do is actually create the database external tables that hosts this data. And that will help us processing our data later on, as we no longer need to carry around the location of the file. Instead, we can reference the data to the table name itself, and that would help us streamline our code a lot more in the future, as sometimes the storage location might change, but that won't affect the table location, as that would be corrected at the table level already. So what that does is right now the code says if the bronze layer, if the schema doesn't exist, then create it. If it doesn't do anything. And it's the same thing for the external table itself. So one good thing about Delta Lake is that the Delta Lake format is actually keep tracks of histories for you. This is one thing that Parquet is not able to do, and it's very hard to keep the versioning of changes that take place. And this capability is very similar to database capability, where you can revert back to a previous version if you need to. You can see in this particular example, after we roll the data directly into the storage account and created a table, it shows you how many the metrics that we have in terms of the number of files that was created in our Delta Delta Lake folder, and how much bytes and size it was written out. So for demo purposes, the next step that we're going to have in Silver is we need to do some deduplications. Now, of course, this data doesn't have any duplicates in it because it came from source and it only happens once. So what I'm going to do here is I'm going to run this block of code. Normally, you wouldn't have this code in your in your operational code. But what this code does basically is we write the data again into the bronze layer of our Delta table. So now we should have duplicate amounts of records. So we're gonna take a quick look. After we roll the data, we should expect there's two versions of the data now. The original write, which is version 0, and then the new write that we just made, which is version 1. And as you can see in the operational parameter, the first write that we made, it was an overwrite, right? Because this data set didn't exist earlier. And then the second one was appending the data on top of it. So let's double check that, right? So let's run the SQL query, and in Databricks, you can mix between PySpark and SQL and Scala. So in my case, I'm mixing that with SQL, and we can see that, a lot of the records that we have are actually having a count of 2, which means a duplicate has been created. Okay. We'll do a little more checking here. So now we're grouping by the processing date. As you can tell, through our conversation, we should expect 2 different processing dates, right? One for the initial run and one for the second one, and then the number of records that we have for each one. So as you can see here, there's a little over close to 52,000 records for each of the time that we ran the data set. So now the last step you would do here is you are trying to do some maintenance to your Delta table. So to do the maintenance in your data table, similar to how databases, sometimes you need to provide some optimizations to the table so that it's so they have a maintenance window where they cleanse or they group all the data together, they clean up some of the data files they have in the backend. So this is very similar how that would work. What optimize does, the command optimize, is to essentially move the records around in the Delta Lake so that it makes it reduces the number of files exist in the Delta Lake. So in other words, it groups all the files together, so it enables you to read the files a lot more efficiently. And then vacuum is there to remove the old version of the data. So once you do that, then you will not be able to go back to the version of the record that are past the vacuum date that you specify. So by default, your vacuum date is anything in the past 7 days. You'll be removed, and you will not be able to recover those data once you deleted the data records and whatnot. So the reason why we do that is as we keep track of different versions, the data sets gets bigger and bigger and bigger inside Delta Lake. So by running the vacuum, you will actually remove a lot of the unnecessary record that you might not ever roll back to, right? So even in a SQL database, you would define a rollback period that you can go up to. Maybe it's a 30-day, maybe it's a 90-day rollback window. So after that, it'll be you might need to go back to tape to restore it per se. So after running vacuum, we just want to quickly show you what that looks like, what happened to the history. So as you saw earlier, we did the 2 write, right? One was an overwrite, one was append. And then when we run the vacuum, it shows that the newest version is 3. So it cleans up all the older version underneath it. So we won't be able to roll back below that point anymore. Okay. So now at this point, we have completed the process from bringing the data from landing to bronze already. So let's examine the next step that we have, which is now taking the data from bronze and bringing it into silver. So to do that, we need another notebook. Technically, you can do them all in one notebook, but it's a better practice to separate them, as that will allow you to run each of the component independently without having to run both of them. Especially if you have a very large data set, that will be quite time consuming. So we'll run through this notebook as well in and I'll point out some of the differences between the bronze and the silver. So in the configuration side at the top here, it looks very simple, similar. We have the new location for the silver. As I mentioned earlier, we will refer to our bronze data through the table name instead of through the storage location name. And then our new table name will be is defined under the silver schema. So with the parameters, it looks almost the same, but it's a little bit different. So we still have the pipeline run ID that is still important to us. And then the bronze processing date, this is the processing date that we added in the bronze layer a second ago there. So this is allow us to pick only the record that has changed or that's newly added into the bronze layer in order for us to process those data instead of processing everything. So so exactly in command 5, this is exactly what we're doing. We're filtering the data to only select the data that are as of the bronze processing date. Now, mind you that if you recall the bronze table here, we need to make sure the date is being cast into a two dates, just so the dates will be comparing the right format with it, the data type with each other. So now with that read in, let's take a look at the data itself, just to make sure we actually are reading the data in correctly. One thing I just want to highlight, and I skipped over point out, instead of reading a file or reading a format, in this case, when you're reading from the table that we created, the bronze table, we just go spark.read.table. Again, that's just a short that help us not having to need to know what the location of the file is. Okay, so the next one here, again, is printing out the schema of the bronze layer we just read in, and as you know, we discussed previously, the measurement date is a string, which again, it should probably be a timestamp as what we saw earlier. So at this step in command 8, we're going to apply some data quality check to our data. As we, there's a few things we want to do: data quality check, data duplications, and make sure that we have the correct structure and metadata in our data. So we'll go through each of those 3 steps one by one. So first, data quality. The business tell us this data should only be between 5 to 20 kilowatts. So we need to check to make sure that any data that we have is between it's not null, so it's not empty first of all, and it's between 5 to 20. So if it is, if those are the record that exist, then we do not want them. So in this case, I give it the name clean in this case, so we know that it passed the data quality rules. The next rule we apply is we need to make sure that the measurement date is a timestamp, because we need to cast it in a second here. So if anything that doesn't structure or format like a timestamp, we need to make sure we discard them as well. So finally, in order to find all the error records, you take the original data set, which is the bronze data that you read in, and you subtract the clean data. And that's your error data set that you have here. Now, taking this clean data set, we now need to find out the duplicate record. As you recall earlier, we inserted the data 2 times, right, with 2 different processing dates on them. So this data, we know that this data is unique by the measurement date, the meter ID, and then the zip code. And what the Windows function in this case does is very similar to like a group by. So we want to group by all those data, and then we want to use the input file modification date to find the newest record in the data set. and anything that are not that are older, we're gonna discard as they are not required, right? So this is what this window partition by is doing. So this is just giving us we're defining like how the data needs to be grouped together and aggregate together. And then at the bottom here, we're going to say for this definition, we're going to generate a row number. We're going to give a number for each of the row that comes in that are grouped together, and we will only get the row number equals to 1. So in other words, the oldest record, because when we're sorting this data, we sort it by descending order. So the next thing we'll do here is we'll quickly run some row check to make sure we're able to find all the duplicates if there's no error and so forth. So as you can see here, we didn't find any data quality rules, which is a good sign. Our clean data coming in after the data quality check, it's a little over 10,000. And we found about half of them, exactly half of them was duplicates, which is what we expect to happen. So normally, one of the best practice would be for you to write out any Air data into an Air folder, just so that the data engineering team can go analyze it afterwards. But in this code, I didn't include that, but you could store that in many different places that the team designed to. But yeah, it's good to ensure that you write any of the error records out, as or else you will lose that the records, and you'll be more challenging to figure out what was processed, what hasn't been processed. The next step here is to correct our data structure. Now, as we talked about a second ago, the measurement dates needs to be a timestamp, and we already checked this to make sure everything can be cast into a timestamp. So we expect this to be naturally happen without any error. And then the second one is we're casting a double into a decimal type. This is more of a standardizations or preference that that we decided to go with. We want all of our numbers to be in a decimal or an integer or a big integer in that case, so that we don't have so many different number types to use. And then finally, we will rename the input file modification date to be just the record modification date. We add in the pipeline ID, the processing date that we talked about earlier. And since this data came from bronze, we're going to drop the file name, as we do not need that information. Now, with all of these changes applied, let's take a look what the data set looks like. Okay, so as you can see, we dropped the file name column that we have here. We did all the renaming that we talked about a minute ago. We did not lose any digits in the decimal conversion, and our dates came across correctly to the timestamp format. Okay, now you may ask, well, how do you make sure this is actually a timestamp? So when we can take a look at the data frame above, and this is the schema definition that came with the structure. Finally, now we're getting to the point of merging the data together into our silver table. The merge from the silver layer is very different than the adding the data in the bronze. In the silver, we actually have to segregate and find out what data we need to update, and we need to insert instead of just blindly adding the data in. So again, if the date of the measurement, the meter ID, and then the zip code where this meter is sending data to, if all these values are the same, then we know that this record already exists in the silver table itself. And if it does exist, we need to make sure we only update it if and only if the record modified date is newer. So the data that came in is newer than the data that was already processed in my system. And this is to prevent issues with data arriving late. You don't want to overwrite the wrong record with a corrupted value, for example. And if anything that doesn't match this initial condition, we're just going to add it directly into the silver table, the silver location. Now, the first time you run this, since the silver table doesn't exist, you would only execute the bottom part, which is just the overwrite, which is what we did in a bronze as well. But if you run this one more time, then you will actually come into the update statements there. Okay, just quickly got to run through the same kind of code for creating your schema and an external data table. Now, just a quick sanity check for some with some of the select statements. Normally, you would not do a select statement like this inside your production or operational code. You wouldn't do any display naturally, but in the form of the demo, we'll do them so you guys can see the output here. Okay, so yeah, this is just one of the meter ID that I'm familiar with the zip code. We just want to make sure we only have one of this record exists in our system. If the deduplication fail, you would have two essentially here. Then finally, we'll do the vacuum, which is the same thing that we ran in the bronze layer there. Okay. So now our data should exist in both the bronze layer of the data lake as well as a silver layer of the data lake. In a silver layer, we did a lot of cleanup so that hopefully we can use it for our next step in the process. So as we discussed just a second ago, the bronze and the silver layer has been completed. Now let's talk about the gold layer that we have. So hopefully this diagram, you guys are familiar with it from a second ago, where the diagram is a lot more focusing at the JSON file that's coming in, and we did the bronze and the silver processing. Now we expanded the gold area to show the different projects that we have coming in. So in our case, we have 3 projects that we're focusing on. Project A, which is the power consumption project, in which you're trying to track and measure the power generated at each of the power station for a specific duration. In Project B, the field inventory project, where you're trying to track the amount of fuel that you have at each of the power station. And for Project C is where you're tracking any plant maintenance activity. So if a plant needs to be shut down, or if a specific meter needs to be shut down for maintenance, then the plant's manager, for example, needs to be aware of that, as that would impact the services for each of their customers. So as you might quickly identify that in all 3 of the projects, there are a lot of similar data elements that we talk about, a lot of similar business data that we talk about, and this is all surrounding around a power station. And you would also notice some general dependencies or things that are dependent on each other. For example, you would know that when you need to generate more power, you need more fuel, for example. So you would expect your measurement to go by higher, but your fuel count to be lower as time go by, right? If there's no additional fuel being delivered. And of course, naturally, when there's a plant maintenance going on, the total amount of generation at that power or a specific meter you expect to drop as well. So you can quickly tell that the silver layer, the job the silver layer has done has been great. It's saved us from cleaning up some of the data. But if we create a data model for each individual project, we are basically duplicating a lot of the data again. So is there a better way for us to reduce that and perhaps create something that we can share across all of our projects. And we can do this through something called dimensional modeling or dimensional model. So a dimensional model is made up of two components, dimensions and fact. So as a dimension would keep track of the description of an object. So for example, when you have a power plant, how big is a power plant? It's something of a description of an object. And for example, if it's a grocery store, you might have a dimensional table that store all the produce like apple, oranges, bananas, and so forth. And a fact would be would be used to measure what do you want to track. So using the grocery store example again, you might want to know the inventory of the produce that you have, right? You want to know how many bananas or how many oranges, how many boxes of oranges you have, for example. So, and because of that, in order to describe the fact table, what you want to measure or KPI correctly, you often will need more than one dimension table, right? And as a result of that, you quite quickly can, because they're related, you form the relationship, and it looks like kind of like a star shape quite often. So some people also refer to dimensional modeling as a star schema in this case. So let's take that example of the grocery store and let's expand it on a little bit. So let's just say we do want to measure the fact table. We do want to measure the amount of green apple being sold at this particular grocery store downtown. So this is, we want to track that. We want to track that number as the green apples are being sold. Now, we just talked about that. This is, we want to know that for a particular store, but you might want to track it for all the store as well. And that's because of that, you need to store, the store information, right? Like this is the downtown store at what city and what is the zip code that's being an address of this the store information. So the next thing is, if you want to know how many green apples being sold, you need to know which day this number of green apples were sold, right? Or month or whatever the time frame you want to, or the grain that you want to measure, track the data with. So, some of the other interesting facts you might want to measure is, do you sell more green apples on a Tuesday versus a Saturday? So your date data usually contain more than just the date itself. It contains various different representation of the dates. Is it a Tuesday? Is it a Wednesday? What month is it? Maybe summer month, we will sell a green apple a lot more than red apple would be, for whatever the reason is. The next dimension we have is the organizations. So, in this case, we're looking for green apple, but if the organization want to see how much money each department is generating, like produce versus frozen food, for example, right? So you need to establish a structure so that you can relate your data, assign them back to what department of this data belongs to. So the next one is lookup, a lookup dimension. A lookup dimension, some people call it a reference dimension, is you look to see some reference data information. So a good example of that is you might have a particular barcode that's associated to the green apple. And so you store all your barcode into one dimension, and then that's easier for you to look up. And finally, you have the produce itself, in this case, the green apple that you want to track, right? So you might have in your produce dimension, you might green apple, red apple, oranges, all of those things will be in there for you to track, and you just have to filter out the green apple that you're interested in that case. Now, let's take that example that we learned from the grocery store, and let's talk about how we would build our goal layer for our power plant. So in this example, we only have 4 different dimensions with one fact. And that can be the case, and sometimes you will have more than 5 dimension tied to the fact. So it's just deep case by case basis based on what you need. So what we have here at the top is the power station dimension. Kind of we hinted on that earlier. At the power meter, what kind of attribute does it have? How much power can it take on? What kind of load can it take on, for example? The next thing is we need to know the power that's being delivered. Where is it being delivered to? Where is it being serviced? So in this case, we have some kind of we need some kind of dimension that tells you that, oh, we're servicing this geographical area or this particular city or area within the service area. We need to know when this data was this power was generated, and we separate the date dimension with the time dimension. So those are 2 separate components, and that will allow us to do some more enhanced analysis in the future, right? For example, in the time dimension, you might be interested to know throughout the year, do we consume more power in the morning versus in the afternoon? Is it during Saturday, Sunday morning compared to the weekdays morning, for example? So it gives you a lot more flexibility in terms of analyzing the time of the day, if you will, versus the day of the week, if you will, in that case. All right. So with that, let's jump back over to our code here. So so this is the 3rd file that we have, and this is for the goal fact table. Now, as you saw a little second ago in the diagram, in order to build the fact table, it requires all the other dimension tables to be built already. And throughout the demo, we only saw the this power consumption data set being processed. And that's because due to the interest of time, I won't be able to show you all the code for the dimensions, as there's quite a bit of that I need to go through. But I'll include them in the Git repo for your consumption as you want to run through them or process them, whatever not. Okay. So in this case, as we mentioned, there's 4 different dimension table that needs to work with this fact table that we're building. And this fact table is belong to the production department that we have. So this is the silver table that we have, and this is the gold table we need to introduce. And then finally, there's also the location where this data needs to store. Okay. So pretty similar to before. Instead of a silver processing date, we have a bronze processing date. We have a silver processing date. In our case, it's the same date as what we have. As you know, that's the time of the day that we have here. So the pipeline ID, again, I give it a unique pipeline run ID. When we run through this through Azure Data Factory, you will be the run ID that comes from the data pipeline. The one big difference between all the processing we have so far, regardless if it's a DIM or fact table, is we need to define the structure of the table first. As you saw previously, all the table that we create are based on the data frame structure that gets produced. But in our case, we need to create this. And that's because we're using one particular column called identity. And what the identity column does is it shows it automatically increment that the value of the data as you insert data into the table, and you guarantee to be no duplicates. before this identity column, we would have to, for example, do a row count of do a maximum number from the goal table, and then take that number and then increment it based on the row counts, the row number that we have to generate the unique ID. But this is a lot more safe, as Databricks will be helping us managing this particular value. So the SID here, this is basically your primary key. You can think of it that way. It is unique across the whole table, and then you're referencing all the other dimension table through their SID as well. So you won't be referring them to the, let's say, the meter ID, which is a string. You're referring to the actual SID itself. It's called surrogate key, or for short, just SID. And also in dimensional modeling, often we do not establish foreign keys constraint. And this is done on purpose. In case if we need to reload the dimension table, then we can reprocess we can easily reprocess the fact table without having to drop or remove all the records in a table, which is a lot more cumbersome. So pretty similar here. The next thing we'll do, we read the silver data in. No changes to what we did in the silver step. Now the next step here is we had to do a slight workaround, and that's because the measurement date actually contains a date and a time, and we need to pull those two components out of the data set into separate columns, because those are two different mappings to the dimensional table. And that's why I just call them temp for now, as they will be going away after we finish using them. Okay, so now after we split it, we'll just take a look at the schema that it produced, and also displays the data here out for you. Okay, so no surprise here. The silver data, that is a timestamp for the date, and then the kilowatt is a decimal as we defined it. And then the two additional column that was produced as well for the dim date and dim time. Okay. Now, this is where we need to start processing all the other reading in all the other dimensions in order to find the match that we're looking for. So there are four of them we're looking for: the dim date, dim time, the power meter that we've been working with, and as well as the service location that we spoke about. So in here, the easiest way to do this is to just minimize the amount of column that you bring in. Quite often your dimensional table could have many columns, over 10 columns. It's pretty easy. So just pick the columns that you need instead of over flooding the system here. And in our case, we're going to provide the name with an alias, so that we just do a name change on that column, so we don't run into collusions with the existing data set. So you see that in multiple places. For the we use the calendar date column, which is the string representation of the the date representation of the business key in the dim date, and then we're using that column we'll be matching it with the temporary dates in a second here. Okay, and then the output that we want the match to be is the SID that we said a second ago. So we do that for all four tables. We identify which key is to use to match the data. So for example, meter ID is a key, and then the zip code, it's also a critical column for us. The next step here is we're going to do a left joint to all the data sets. And the reason why we do a left joint is there is occurrence in the real world where we won't find a match. And in the case we don't find a match, we do not want that data to be lost, that measurement to be lost, because if we lose it, then that is a lot of problems that we will have. So the standard, we will set anything that we cannot find as a -1. Okay, so that's why we did all the left joins up here. The next step is we simply just selected the column that we want. So we abandon all the record that we have above that we don't need. And then we do a quick search, basically look at each of the column. If the column with the SID in it that is null, then give it a -1. If it's not, then whatever the initial value that we're checking with. So we just did that for all 4 of the SID here. So finally, we need to correct the data structure that we have and generate a few of the metadata that we got. And in this case, majority all of the data types are correct. We need to do three things. Number one, we create something called key hash. What a key hash is, basically we're doing a hash on all the key column concatenated together, and that give us an easy way to compare if this record already exists in the fact table or not. The value is exactly the same thing, but in our case, we only have one thing we're trying to track, and that's the kilowatts that generated. So in this case, it's only one value here. Okay, we're just going to do a quick rename of the column because we renamed it in the definitions that we have to be more descriptive towards what we need. So that's the power consumed in kilowatts. We have the pipeline ID and then the processing ID. So as you go through this code in the dimension, the steps are very much the same, except of course you won't be doing the joins with any other table. Dimension table usually operate on their own. But you will still see the key hash and the value hash. And in the dimensional scenario, the number of columns for each of the hash is actually flipped. They only have one, usually there's one, maybe two items that goes into the key hash, and then you might have 10 to 15 element that goes into the value hash in that case. So just quickly run that, and then we'll display the data before we do the merge, just to make sure everything is correct. Okay. Again, usually the display will not be part of the operational or production script that we have. So we can see all of the meter ID that we have. Initially, those are have a particular string format that we have, and now those have become numbers. And we have our hash values here with the new pipeline ID of 3235, and then the processing data just now take place here. Now we're going to merge this data. As we discussed earlier, the dim and the facts is going to merge very similar. We're going to be using the key hash to do the merge. If this key hash has been found, then that means the record exists. Then we're going to compare it based on the value hash. So if the value hash has changed, then we know something has changed in this record. Then we better update it. If this key hash doesn't exist between the data that we're processing versus what's in the actual table already, then we just insert. And you might notice that we don't have the SID column in here because that's going to be system generated for us. Unlike previously in the bronze and the silver, we do not want to create the table based on the schemas generated. If the table doesn't exist, you want to actually throw an exception, as a dimension we create will not have an identity column, and that's going to cause a lot of issues for us later on in our processing. So looks like everything got written out now. So we'll just go do a quick select on the table, and we can see the data came straight through as we discussed. Now the final step is just running the same maintenance cleanup to make sure all the data are cleaned up correctly. So I'm sure, the first thing you notice is we're running this notebook one by one, and we're running each of the cell one by one and not through Data Factory. So we'll definitely get to that in a quick moments here. But before we do that, I just want to show you this data can be served up in Databricks through something called Databricks SQL. And you will get how you get to there is on the left panel here, you can click on the SQL editor. And this will bring up the the SQL, the Databricks SQL screen here, which is a little bit different than what you probably traditional experience with the notebook. So in here, you can create your own query. You can technically have this SQL data warehouse available for a data analyst or the business team to come in and query data. And in here is straight up query, SQL query. There is no Python or Scala that they need to deal with. And in this query, just something I threw together pretty quickly. I'm trying to get the top 10 power consumption that took place for a specific based on the zip code that it has, and you can quickly through a map together that you can see who are the top 10, which are the top 10 area or zip code that has the highest power consumption. Okay. So the one last thing we probably want to touch on in Databricks is how do we get this configuration to work? As earlier we talked about, all of this table that we created is actually created outside of Databricks. They are stored in our storage accounts, and we need. And for every single notebook that we ran, you saw we need to pass in a secret or password to it at the beginning. So how do we go about dealing with that? So in the admin console here, just want to bring that up really quickly. There's a SQL warehouse settings. Of course, this is something you need your administrator to help with. So and you can tie this to a specific system account that you can make, which is called service principal. But essentially, you can configure, you can pass in the Spark config into this setting here to enable you to access the storage accounts itself. Without this, you will just get an error saying that you don't have access to those data. Okay. Now, yeah, so that kind of wraps up the Databricks piece, right? Now, this data is all good and dandy inside Databricks, but can we get this data out to Power BI, for example? So here is a quick Power BI dashboard I just do together. Try to, let's see, get this data set refreshed so we can actually see the data coming across. Okay, so in Azure Data Factory, I actually created two different pipelines. It might be make sense to create more than just two pipelines here. For me, I just kept it relatively simple. Create two different pipelines for us to move forward here. And the two pipelines that I created is just the general data. So what the general data provides is the dim dates, the dim time, the zip code, and how the zip code get converted from bronze to silver and then to gold. And then I have an IoT smart grid pipeline, which actually process the power consumption data as well as the power meter information. Okay, so we'll step you through how this pipeline is constructed. As it does take a little time to run this normally here. So make sure we reset some of the resources here. Okay, so all of the parameters that you saw previously, we have to define them inside each of the notebook. So when you drag a notebook into the canvas inside ADF, I'm hoping the team here are familiar with the Azure Data Factory, as one of the previous sessions we kind of deep dive into that already. So so in the Databricks, you select the link service that you created. And in our case, our link service connects to the Databricks environment that we talked about earlier. We will pass in the pipeline run ID, like we saw earlier. And in this case, the landing folders go back to the parameter of this pipeline. So this is just a simple way for us to collect all the parameters instead of having it across all of the different notebooks. You just set them one by one. So this is the exact same setting you saw earlier. The processing date is the 29th, and the landing folder is this location. Now, the reason why we set this up as a parameter, other than consolidating all the configuration, is when you add a trigger, you can modify what those two dates are. This is just a default value for our testing purposes. So this would be the trigger window start time, for example, and then the landing folder would be also changed based on the processing time that you're looking at here. So this is basically the same setup across all of the notebook. And as we talked about, this process you might run this every hour, let's say, right? So you want to always make sure that the power meter or all your dependent dim tables are being processed first before you try to process the actual fact table in Go. Okay. So with that, we can actually just run this while we are trying to fix the Power BI piece. Okay, so let me drag the Power BI piece back in. So right now I just have it on my Power BI desktop. Not sure what's happening on the in the cloud version, but you can see the map is not happy with me as I'm trying to let me just quickly fix this, as my Power BI desktop is not have the map turned on. So just give me one quick second to fix that as well, while we wait for the data to be processed. Yeah, there we go. Let's see if this make the dashboard happier. So while we wait for my Power BI to get back happy with me, we'll take a quick look at the general data. So for the general data piece, usually this is the pipeline that you load data that doesn't change very often, or like reference data that we have, right? Dim dates, usually you run this maybe once a year. Dim time, you usually don't run this at all. You run it for, this script is set up to run it for the whole year, for the whole day time frame. So you should never have to rerun that. And then for the zip code reference data, you should that should rarely, if at all, changes. So we don't expect those to change very often. So we could split those into two different pipeline here. So while we're still waiting here, this is how the Power BI report would look like here. And yeah, so you can see, based on our selection, the power consumption would change. The map location would change. So the our zip code is around the Seattle, so we're servicing the Seattle area, and you can see the amount of power consumption used in during the day that we provided. It requires some additional formatting, but this is the kind of the gist of able to connect Power BI to Databricks. Okay, so since in the interest of time, we're going to just wrap it up here and go to the Q&A, and we can take a look at the end if the ADF completed. So yeah, it has been a So in our meeting here today, we talk quite a bit about the Medallion architecture. How is it going to help us removing any duplicate processes that we have? And this will save us time and money and effort, and even headache as well as we troubleshooting code, so we don't have to copy and paste code across different projects. And we adopted the star schema or dimensional modeling for the goal layer. This allows us to create one model to be reused by multiple projects. We don't have to reprocess another power station, for example. So this helps us keep our data consistent across all the projects, enable us to reuse and complete our project faster. Again, all the code will be available that you see on the screen probably in a couple of days. So please go check it out, as I'm not able to go through all of the code that I've written for the project, including the dimension tables. So please go in and have a quick look. And yeah, so at the end, you saw the Power BI report connect to the Databricks SQL in Power BI Desktop. So this is the third installment of the series. So the next and the final installment will be focusing on streaming solutions using structured streaming as well as Delta Live Table, and that will be on September 29th. So with that,